All right, good afternoon, everyone. Hope everybody's doing great and everybody is all right. So, fortunately, we had to switch classrooms. That's what took me so long to log on. Technology wasn't working in our normal classroom. We switch and get everybody in here. So, this is where we start. Yes, a little breezy in here. So this is where we started last class. We left off right here. And so if we get a few more seconds for everybody to get in, and then we'll go ahead and get started. And pay attention to your emails. We may switch classes. If that technology in that room, the technology in that room keep acting funny, because it was acting funny before now. I was able to fix it before. So if we do decide to switch classes, I will email y'all and let y'all know. So just pay attention to your emails, as always, right? So last class, we talked about graphing on the rectangular coordinate plane, Cartesian coordinate plane. And we covered creating an XY chart and graphing using your intercepts. So we did that for our limit equations. And so this is where we left off. Well, going into this is where we left off last class. So we're looking at horizontal lines. So notice the difference between this equation and the equations of before this one. If you were to go back and just scrolling up real quick, notice how this equation has X and Y involved, but this equation only has Y. Whenever you have an equation that just says Y equal to a number, that is going to give you a horizontal line. And so here we have Y equal to 5. That means that no matter what X is, or X can be anything, but Y will always be 5. So if you had to create an XY chart, like here, I just did -1, 0, 1, but 5 is going to be Y all the way down, or Y is going to be 5 all the way down. All right. Yes. What we did last class. Yep. So this is the beginning of today's class. So we're still in C1. Good question. Good question. We're still in C1. And we're picking up right where we left off. And so if you were to graph those 3 points, you go to the left 1 up 5, 0 up 5, and then to the right 1 up 5. And notice that gives you a horizontal line at 5. Scrolling up some. So this one was y equal to 5. So the outside, not outside of that, but the opposite of that, we have x and y involved. And before we only had y, this time we only have x. So if you only have x equal to a number, then you should get a vertical line. In this case, we have x equal to -2. This means that y can be anything, but x is always going to be -2. So if you were to graph those 3 points, go to the left 2 up 1, left 2 up 2, and then left 2 up 3. And that gives you a vertical line at -2. Everybody good? Can I go to the next thing? So I gotta go to the whole next page. Everybody okay with copying? All right. So let's look at the third way of graphing. These are linear equations, and that will be with your slopes. And so your slope is a numerical value, mathematically is a numerical value that represents the slope or the incline of your line. So just think about the slope of a mountain or the incline or the slope of a ramp. Just put in a numerical value to that. So M is going to represent our slope. We couldn't use S because S represents other things, especially when it comes to physics. So we're going to have to use M. So the way we'll calculate is that we can either do y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Doesn't matter which one you do first, as long as you stay consistent. Notice how if y2 is first on top, then x2 need to be first down bottom. Or if y1 is first up top, then x1 should be first down bottom. The x1, y1, x2, y2 comes from just any 2 points on the line, the coordinates of any 2 points in your line. Also, this last piece of rise over run is what we'll use when we actually get to the graphing part. So we'll talk about that in a few. Scrolling up some. So let's take two ordered pairs and calculate the slope. So if these 2 points existed on the same line, what would the slope for that line be? So it doesn't matter which one you call point 1 or point 2. I normally just label the first one I see point 1, the second one point 2. Just have to be consistent throughout your calculation and your formula. So x1, y1 is -2, -4, x2, y2 is 3, -5. Everybody holding on to that top part? So like I mentioned, when we first started talking about slopes, that you can do y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. So I'm going to do it both ways for this first problem, just to show you that either way you'll get the same answer. Remember, whenever you're doing it on your own, you only have to do it that one time. All right, somebody's asking for, is that enough or you need more? Let me know. Okay, cool. Thank you. All right, so let's go ahead and plug in. Whenever you're doing your substitution into the formula, always make sure that you're careful and you're not losing negatives when you go about your substitution. So there's a minus sign in the formula, and then we're plugging in negative values. So y2 is -5, y1 is -4. So it's -5 minus -4. And then in our denominator in the bottom, we have 3 minus -2. X2 is 3, x1 is -2. So that's 3 minus -2. So don't forget negatives and negative turns positive. So it's -5 plus 4, then 3 plus 2. Then -5 plus 4 is -1, and 3 plus 2 is 5. So our slope is -1/5. Say again. Oh, we'll talk about that in a second. Okay. It doesn't really mean you can write that down if you want, but that's really, I'm just going to emphasize something in a second. So. I'll scroll up some. As always, if I go up too far, let me know. All right. So same problem. Like I said before, though, what I wanted to do was show you that y1 minus y2 over x1 minus x2 will still give you the same result. So this time you plug them in the opposite fashion: -4 minus -5, -2 minus 3. So that negative negative turns positive. So it's -4 plus 5, which is +1. And then -2 minus 3 is -5. And that's the same thing as -1/5. So what I was doing up here in the red, I was just emphasizing that if you have a negative in the front of your fraction, that's -1/5, or negative up top, that's -1/5, or 1 over -5. All of those are the same thing. Just as far as notation goes, very rarely do you see the negative sitting in your denominator. Either they'll bring it out front or pull it up top. And so that's why I put the box around those other two. But I just want to emphasize those are the same thing. That's all. Mm-hmm. Yep. Just have to be, once again, just have to be consistent. Y2 first, that means X2 first. Or Y1 first, that means you use X1 first. Questions on that one before we do at least one more and make sure we do it. All right. So next one we have 5, -6, and then 8, 3 as our two ordered pairs. So I call the first one X1, Y1, which is 5, -6, and then 8, 3, I call X2, Y2. Y2 minus Y1 of X2 minus X1 means I would do 3 minus -6 over 8 minus 5. Once again, negative to negative turns positive. So that'll be 3 plus 6, which is 9 in our numerator. Then 8 minus 5 is 3 in our denominator. 9 over 3 is 9 divided by 3, which is 3. All right, very good on that. All right. Next one just for your basic behaviors of your slopes. Uh, so if you were to follow your graph from left to right, if it's going up, then that means your slope is positive. If it's going down, your slope is negative. If you have a horizontal line, your slope is 0. If you have a vertical line, your slope is undefined. All right, everybody good on this? My guy scroll all the way up. See? Undefined. That means you ultimately get 0 in your denominator. So just calculation thing, but they just call it undefined in mathematics. All right, can I scroll up? Very good. All right, don't copy this yet. Y'all don't need this. All right, here we go. So graphing using slopes. So, like I mentioned, initially when we started talking about slopes, we have a relationship called rise over run when it comes to the numbers that create your slope. So the top number is going to reference your rise, which is up or down. The bottom number is your run, which is left or right. So what dictates whether you move up or down versus left or right is whether you have a positive number or a negative number in your numerator versus your denominator. So for your positive moves, that would be up and right. Your negative moves would be down and left. All right, so First example, if I have a slope of 3/4, that's a +3 over a +4. So it means I would go up 3 and then right 4. Those are two positive moves, two positive numbers, or two positive numbers. So I'm making two positive moves. So it'll be up and right. Right, holding on to that top. Right. The next one, we have to be careful because sometimes, we make the mistake of assigning that negative to the top and bottom. We kind of alluded to this already, the relationship with that negative when we looked at that 1/5. That negative sign goes to either top or bottom. It does not go to both. So you have to make a decision. Normally, I just give the negative to the top number and just go on, with the process. But if you do assign to the bottom number, you still get the same number, still get the same, we still get the same line. So if it's -5/7, that means you're going to go down 5, right 7. But if you put the negative down bottom, that means you will go up 5, left 7, because it's +5 over -7. And so what's going to happen is that when we go to graph, you'll see the instructions in a second. You'll have a point. And so let's say you go from this point. If I go up 5 and left 7, I'll be right here, which will still create my line. Or if I go the other way and go down 5 and right 7, I'm still going to create the same line. So as long as you stay correct with giving the negative to top or bottom and not to both, either way, you'll still get the same line. I scroll up. One more thing before we actually graph using our slopes, and that's the slope intercept form. So it just says that if I take my linear equation, solve it for y, and then simplify as much as I can on the right side, I will be able to easily pick out my slope and my y-intercept. So the number that's sitting right in front of x will be my slope, or you say the number that's attached to x, that will be my slope. And then the other number will be my y-intercept. Remember holding on to the red up top? Red, red, red. All right. All right, looking at our examples here, I have y equal to 2/3 x plus 1. So it's already set up in slope intercept form. So the number that's sitting in front of x is my slope. And notice my slope is not 2/3 x. It's just the 2/3. Some people, by mistake, will pick out 2/3 and the x and put that as your answer. No, if they ask you for the answer for the slope, your slope is just 2/3. And then your y-intercept is the 1. And then for the next one, I have y equal to -8/13x minus 5. So my slope is -8/13, and my y-intercept is -5. All right, scrolling up. All right, so here are directions. So the graph using slopes on two steps. First, you're going to plot the y-intercept first. That's always your first move. You plot your y-intercept, and then you're going to generate another point from the y-intercept with the slope directions. So we're not going to take those slope directions, up 3, right 4. We're not going to come from the origin. We're going to come from that y-intercept to generate another point. Mhm. And I hold on to the red. All right, so we have y equal to 2/3 x minus 1. We're going to go ahead and implement that process, see if it can work for us. So the equation's already solved for y, so it's already in our y-intercept form. The number in front of x, 2/3, is our slope. The -1 is our y-intercept. So remember from last class, we talked about our x-intercepts and y-intercepts and characteristics of both. So we have a y-intercept here. So we know that for our y-intercepts, x is always 0. So if I wanted to plot that point, the ordered pair for that would be 0, -1. If my y-intercept is -1, x is 0. So it's going to be 0, -1. And then for my slope, I have a +2 over +3. So that means I'm going to go up 2, right 3. Yes. Yes. Mhm. So we're going to graph that 0, -1 first, like your classmate mentioned. That's right here. Just going to go down on your y-axis. And then from this 0, -1, you're going to go up 2, right 3 to create another point. And once you have your 2 points, you can graph the line. Mhm. Questions before we look at another one? All right. Here we have y equal to -1/4 x plus 3. The -1/4 that's attached to the x is our slope. And the +3 is our y-intercept. So as an ordered pair, 3, this is the y-intercept will be 0, 3. And we have -1 over +4 as our slope. So that means I'm going to go down 1 and then right 4. So you graph your y-intercept first, right here. You're just going up 3. And then you go for your, on your x-axis. That's the x-axis, y-axis. And then from there, you go down 1, right 4. And that'll give you a second point. Any problems? I want to do at least one more. Make sure we're good. Any problems with any of those? All right, so last one. This time, our equation isn't set up like the last two. You know, the last two was already solved for y. This one is not. So I just want to make sure you saw a scenario in which it wasn't solved for y and how you solve for y, and then proceed with your graphing by using the slopes. So we have 5x plus 2y equal to 8. First thing we want to do, once again, we're trying to get y by itself. So the first thing we want to do is move the 5x to the right side of your equation by subtracting it from both sides. That'll give us 2y equal to negative 5x plus 8. Anybody hold on to that last example? Mhm. All right, so then we need to get that 2 off of y. So that's 2 times y. We divide both sides by 2. And we talked about this scenario before. If we want to reduce further, this 2 has to go into each term that's in the numerator. So that's how we got negative 5x over 2 plus 8 over 2. Then 8 over 2 is 4. So now our equation is solved for y. Simplify as much as possible. The number that's sitting in front of x, or the number that's attached to x, is our slope. That's negative 5 over 2. And our other number is our y-intercept, which is 4. So let's go ahead and graph with that information. First thing you want to do, as we mentioned before, is you graph your y-intercept first. That's 0, 4. So you go up 4 in your y-axis. And then from there, you're going to use our slope information. We go down 5 and then right 2 to finish it off. Questions on the process? About to get it right straight. All right, so this is a good place to stop. One reason is because my last class lost internet while we were teaching it, so I try to keep my classes together. So we stopped like right here, and so I kind of want to keep the lectures together. And then also, you know, C2 is just substituting in the functions and everything. So that's like a different conversation altogether. So, you know, we'll talk about it next class. And there's no rush. Semester just got started, so we'll be all right. So, but with that being said, please take advantage of the time that I'm giving you guys without pushing a whole bunch of stuff on you. You got 4 sections in chapter B, and then we got this section out of chapter C, and then one more section in chapter C as well as C2. So I'll probably make one test. Remember, I haven't posted any tests yet. I'll probably make one test out of those 6 sections right there. But I'll let you know once I post it and everything, and then you'll be able to execute that accordingly as well. But any questions, concerns, comments before we close? A homework question? Do you have a general question or a homework question? Uh-huh. No, you can do them on your own. Just show you work. That's on the assignment. We're asking to see work. That's fine. The email. Yep. Yeah, I don't need to take anything from you. All right. So let me stop this recording. And for those who are done, I will see you next class. If you want to have any questions, feel free to stay back. All right, have a great weekend.